Um, so I wasn't in Eric's developer tools keynote, so I have no idea what he was talking about. But I'm hoping that he inspired you all to learn how you can integrate and extend Stash further. And in order to do that, we brought up Jason Hinch, who's a longtime developer for Stash. I think before Stash was Stash, Jason Hinch was working on Stash. So he's gonna. This is a technical talk, so don't be scared if you see some code. We're gonna dive right into it. Jason.
Cool. Thanks, Dave.
Yeah, you can. Okay.
As mentioned, my name's Jason Hinch, and I'll be taking you through how you can extend Stash. I'll be telling you how to get started, going through some of the basics, and then taking you through two plugin points of the many plugin points we have available in Stash. But first, how to get started. So the first thing you need to know is the Stash developer docs. So this is your go-to place for everything plugin development related for Stash. It has Java and REST reference documentation, as well as tutorials and how-to guides for a lot of our plugin points. But before I jump into any of the specific plugin points, I'll take a step back and talk about what is a Stash plugin. So who here has developed an Atlassian add-on before? Raise your hand. It's about half. So a Stash plugin is an in-process add-on, so it runs within the same JVM as Stash itself. So it's sharing all of the same CPU and memory constraints of that JVM. You'll sometimes hear us refer to them as P2 plugins. And technically, these are OSGI bundles, but the main kind of distinguishing factor about them is the atlassian-plugin.xml. So this is an XML file within your bundle, which describes all the modules that your plugin provides. So for those of you that have done an Atlassian plugin before, this will sound very familiar. And that's because Stash is built on the Atlassian platform. So you get a lot of the same modules and plugin points that are available in Jira and Confluence with Stash. You may have heard of the other type of add-on that Atlassian has, Atlassian Connect, where you run your add-on outside of the Java process on a different server. This isn't available in Stash, but we're hoping that we'll be able to make it available sometime next year. But let's jump into the first plugin point that I want to talk about today, and that's repository hooks. So repository hooks are a way for you to gate pushes or merges of pull requests to a repository, as well as perform actions on successful pushes. These are configured per repository, and that's at a minimum an enabled or disabled status, or optionally you can configure arbitrary settings for your hook. You can see that on the right of the screen, the hook settings page. So they're all the hooks that are available in this instance. So what are some examples of what you might use a repository hook for? Well, you could write a plugin which prevents a developer from deleting tags. There's a plugin on the marketplace which ensures that all commits pushed to a repository reference a Jira ticket. You could apply a naming convention to your branches or your tags, making sure that they're all consistent. And you can use them to notify external systems. The concrete example I want to talk about today is the naming convention hook. So I've written a plugin which applies a naming convention to all branches which are created within Stash. And it does this via a regular expression. So you configure a regular expression. If it matches, that branch is allowed. So to start with, we start with an Atlassian plugin.xml. And this is the definition of our module. There are a couple of important parts. There's the name, description, and icon, and these are used in the configuration on the configuration screen that you saw previously to describe what that hook does. Probably the most important part of the description is the Java class. So this is the class that's going to be invoked when a push occurs to a repository. And finally, as mentioned, we need a regular expression to configure this hook. So we've added a configuration form. So there's two important bits of information here. There's the view, which is the template that's going to render our configuration form, and the directory, which is where the template's contained. So if we jump into our Java class, it looks a little like this. This is the bare bones of it. You'll see that our naming convention hook implements two interfaces, the first of which is the pre-receive repository hook. That interface requires you implement one method, the onReceive method. It takes in a repository hook context, which gives you access to the settings that have been persisted on your behalf, as well as the repository that's associated with the push. A collection of ref changes, so this is the branches or tags and the type of change that has occurred to it, so whether it's an addition or a deletion of a branch or a modification. You also get a hook response. So the hook response allows you to pipe information back to the client, so that the developer in their terminal will be able to see an error message. If we jump into our implementation of that, it looks a little like this. Now, I know that's a lot of code on the screen, but I'll break it down for you. The first part is that we have to compile our regular expression. So we're retrieving the pattern out of our settings object, and we're compiling it into a regular expression. The next part is that we're going to iterate over all the ref changes. We're only going to apply this naming convention to newly created branches. For legacy branches which don't conform to the naming convention, or deletions, we don't care. So we're checking whether it's an add, and if the pattern doesn't match, we're going to pipe a message back to the developer's terminal. So we're doing that, and then we're setting accepted to false. So that's then returned. So false return type means that the push is rejected. True means that it should succeed. You'll notice at the beginning of this that I didn't have to validate. I didn't have to catch kind of pass exceptions from the pattern. That's because I was able to validate them before they were persisted. And you may have noticed before I was implementing another interface on my naming convention hook, the repository settings validator. Now that requires you to implement one method, the validate method. It takes in the settings, which is going to be persisted to the database, an error object, which allows you to collect any errors that are associated with, that are wrong with that settings, and the repository that you're storing them for. If we jump into our implementation, it looks a little like this. It's fairly simple. We're just compiling the pattern and catching the pass exception if it occurs, and adding a field error for that exception. So now we've validated it, and we've got our Java implementation. The last piece of the puzzle is our configuration form. Our configuration form looks a little like this. It's written in Google Closure Templates, or SOY as it's colloquially known. There are a couple of important parts to this template. It gets passed two parameters, the config parameter, which is the settings that are going to be persisted at the database or have already been persisted, and any errors associated with a validation attempt. We're just calling into a stock standard text field, which just means that makes the form feel like other parts of Stash. We're giving it a little bit of metadata, or label and description. And we're applying an ID, so the string in that ID corresponds to the same one that we're using in our Java class. And then we're getting the error and value out of the parameters that were passed and passing it into our template. Now, if we put all that together, we get something like this. So we're going to the hook the hook settings page, and we're now able to configure our naming convention hook. We just applied a regular expression and hit enable. Now, if you missed what that regular expression was, all it is that branches cannot contain any numbers. They can only contain letters and slashes. Now, if we jump to the terminal and have a look at what that looks like, if we try and push a branch that has a number in it, you'll see that it gets rejected. And just highlighting the part of the text, that's the validation, the error that we piped back to the user. And if we attempt to push one that doesn't have any numbers in it, it works successfully. So that's repository hooks. The other module type that I wanted to talk about today is file and diff handlers. Now, file and diff handlers are a front-end plugin point, so they're written in JavaScript. And what they allow you to do is plug into the rendering pipeline, into Stash's rendering pipeline for anywhere that we render source on diff. And when I say anywhere, I mean anywhere. Pull request page, change set, compare view, file source or diff. Now, this is really useful for a number of different situations. If you've got a proprietary format that you've checked into your repository, you could write a file handler for that. You could take a 3D model rendering file and render a 3D model in the source view. You could take a CSV and transform it into a table or a graph. And then things like PDF or Photoshop, you could render them and make Stash accessible to different types of users. So the concrete example I'm going to take you through today is the STL handler. Now, STL is a file format for 3D model rendering, and we've implemented it for the source view. So we're not doing diff, we're just the source of the file. So to start with, we start in our atlassian-plugin.xml as we did with the repository hook. And we're defining a Stash resource. Now, a Stash resource is just a collection of JavaScript and CSS files within a particular directory. So we've defined that directory there, the STL Handler directory. The next important part is the context. And this is a way for Stash to include all relevant JavaScript and CSS files on particular pages. So the file handler's context is a way for Stash to include all the file handlers or ones that are related to file handlers on anywhere it's going to render source or diff. So Stash will, provided you add that context, Stash will include this JavaScript on the page for you. And now finally we're adding a few dependencies. So the AJS one is just a couple of boilerplate libraries like jQuery. And we're depending on the file handler's API. And this just makes sure that we're loading our file handler after the file handler's registry on the page. Now, if we jump into our JavaScript file, it looks a little like this now. I know that's a lot of code, but I'll break it down. At the beginning of our file, we're requiring the file handler's module. And when we get that, we're calling the register method on it. We're passing it our file handler. That file handler requires you implement one method, the handle method, and that gets passed an options object. Now, that options object has a whole lot of properties on it which describe where the file is being rendered, whether it's a source or diff, and the path and the revision of the change that you're rendering. Next, we want to do a couple of sanity checks on the context that we're rendering in. So as I mentioned, we only implemented the source view, and this is only applicable to STL files. So we're checking both whether it's not the source view and whether the extension isn't an STL. And if it's not, we're going to reject it and tell Stash, I can't handle this, I can't render this, fall back to your default rendering. We're using a jQuery deferred in this context. Now, if you're not familiar with a deferred, it's also known as a promise or a future in Java. It just allows you to respond asynchronously to a question. In this case, we're doing it synchronously, and we're saying upfront, we're rejecting it, we cannot handle this request. Now that we know that we kind of can, there's a good chance that we'll be able to render the file. We're going to include all the other JavaScript files onto the page that we need in order to render this 3D image. And we do this so that we minimize the number of JavaScript files on all the source and diff pages when they're not required, because we're not often rendering STL images, often it's other file formats. So that gets loaded asynchronously, and when it gets included on the page, our function gets called back, and we're going to actually try and render the STL now. So at the beginning, we're creating a jQuery deferred object, and we're calling our render STL file function. We're passing in the file change, which contains the file path and the revision that we're rendering it at, and a container element. And that's just the DOM element that we're able to have free reign in and do whatever we want in. So that's where we're going to attach our STL image. That's going to happen asynchronously, and it will invoke our callback when that's done. If there are any errors, so for instance, if it failed to pass the STL file, we're going to tell Stash that we can't handle it. It should fall back to its default rendering. So we're going to reject that promise that we created. But if everything was good, we're going to resolve that, and we're going to pass it a stream function. And that allows Stash to call back into our plugin when it's ready to unload load that image, and for instance, in the context of switching between source and diff dynamically, and that just lets the plugin clean up after itself. So if we put all that together, we get something that looks like this. So this is the source view in Stash, rendering an STL file. We're able to zoom in on the image. The developer's able to manipulate it and view it from different angles and apply different filters to it. Do we have any time for questions?
Yeah. First, join me in thanking Jason. And
before we move on, these is all,
wait. Can we flip back for the?
It's all, yeah. Maybe it will come up before.
We'll put the resources back on at the end.
It has all the links to the examples and documentation.
Or we'll just keep flipping them back and forth and try to confuse the hell out of you. All right, let's go to the questions. So we had a couple good ones. If you think of questions, make sure that you you didn't miss your chance. Still go online and ask those questions. Jason is going to be available after to go online and answer all those questions in writing, where you can hold them to you as answers. So what's the difference between a Stash hook plugin and a pull request check plugin?
Yeah, that's a good question. So you still define, I'll explain the difference. A hook or the one that I showed you, is just for pushes. So that wouldn't actually prevent someone from, it wouldn't be invoked in the context of merging a pull request, for instance. There's another interface, which is the repository pull request check interface, which you can implement if you want to gate merges of pull requests. Now, that module you can implement both interfaces if you want, and you still just define it in your repository hook configuration. So it's the same thing, but just called in different contexts. Hopefully that makes sense.
Where can I get a copy of your presentation? I can answer that. All the presentations, actually, are you going to have a link to are your slides already online?
I don't think they are.
So we will have, we're recording all the slides and all the audio, and it'll be available 2 weeks after Summit. We'll email everybody with the links to all the sessions, and if there's a particular session you want, we can collect your information and send you a specific email about this session. So
a lot of this information is actually in the Stash developer docs. If you didn't get the URL before, just Google it, it's the first link. And I think these examples are linked off those docs. Otherwise, I can just answer. I can put these links as the answer to the question. Yeah.
All right, let's see if we can get one more in. Do we have one more? Nope.
All right.
All right. Well, in that case, thank you so much, Jason.